Hello guys, welcome back to Manala's Arc. I hope you've been well. This video I want to talk about linear graphs, and I'm going to try to keep this as brief as possible. Right, let me make sure that I disabled the my blue light filter, so that this video doesn't appear to be too orange or too yellow. Now, for linear functions, let's get to it. I want to choose a pen now, and then we get started. For linear functions, right? When we talk about linear functions, we are talking about straight line graphs. So you will need this equation. I'm sure you've seen this equation somewhere in grade 9, right? However, we don't only use that equation. When we get to grade 10 and grade 11, we use this equation. This is the one that we want in grade 10 and 11. And this is the gradient formula. The gradient formula is as you know it, right? So now, several things to talk about in this situation. Let me put my things properly here. Several things to talk about. I'm going to try to do this freehand from the top of my head as best as I can, right? So first you need to understand that with linear graphs, we call them straight line functions. Linear graphs. Ooh, my handwriting these days is terrible. These are straight line graphs. You see that? Linear graphs, we are talking about straight line graphs. Linear graphs and straight line graphs, it's the same thing, just different ways to call them, right? And then we have several aspects that I want you to look at, or things that we're going to do today. First of all, we have type of graphs, right? We have types of linear graphs. Those types of linear graphs, you will see them. They'll be different. And these types of linear graphs, they're influenced by what? Number one, they're influenced by the gradient. Oh, hope you know about the gradient. By the way, the formula for gradient is m, small letter m, is equals to y at b minus y at a all over x at b minus x at a. I'll go into detail with that soon, right? We have in this situation the concept of plotting graphs. Plotting graphs, I'll fix my handwriting, guys, I promise it will become better. And then we have a situation whereby we are finding an equation for a graph. And finally, we have graph interpretation. Now, this is a whole different concept on its own. Graph interpretation. Okay, my handwriting is coming now. So we are saying we have what? You first need to know about the gradient of a graph. That will help you know the type of the graph that you have. You need to know about plotting a graph. You need to know about finding an equation for a plotted graph. And then you will get to the part of graph interpretation. Graph interpretation, we might not cover it in this video. I would like to do this as a combination of different graphs, right? So I hope we are sorted on that one. So now, let's start with the type of graphs that are possible. So remember, guys, I'm doing this freehand, so it might not appear perfect. Firstly, the type of graphs. Let's put that into writing. Type of graphs. We have increasing and decreasing graphs. Let me put this. We have an increasing graph. We have a decreasing graph. And we have constant graphs. Let me write this one here because this one is interesting. As I'm busy writing these things here, from my mind, I'm like trying to develop the best possible way I can explain this. Like I'm trying to think now, right? So I hope the method that I'm going to use now will work okay for you. So now let's start with increasing graphs. What are increasing graphs? Now, if you use your hand, your right hand right now, to raise it up, right? Like this man here. You see this man here? The one that I just added now. He's raising his right hand up. So if you can get to raise your right hand like that, you will get the direction of an increasing graphs. So let's say this is a Cartesian plane. Cartesian plane right here. I have my x components, my y components, and my x component. So for me, in this situation, an increasing graph, it is a graph that will go this direction, to the direction of your right hand side. You see this cartoon is raising its right hand side. So that's the direction of an increasing graph. It's going that direction. Now, when it comes to a decreasing graph, here we go. I've used this cartoon again. A decreasing graph, this time you use your left hand side. If you raise your left hand side, the direction that your left hand side goes, that's the direction of a decreasing graph. So let's create the Cartesian plane again. Remember, Cartesian plane should always be labeled. This is the y-axis, this is the x-axis. So in this situation, a decreasing graph is a graph that will have, not easy drawing with this writing pad. A decreasing graph, it is a graph that will go straight line, diagonally, but to the direction of your left hand side. That's a decreasing graph. Right. So increasing graph, decreasing graph. Right. So, and then when we are talking about constant graphs now, this is a different story. These graphs, they are not diagonal. These are graphs that are horizontal or vertical. So we have this graph here. Let me do two Cartesian planes in this situation. Y and X. And another Cartesian plane here. In this situation, my constant graphs, let's start with this one. My constant graph can be a graph that is vertical this way. And my constant graph in this situation can be a graph that is horizontal. So these are constant graphs. They're still linear graphs, but they're not increasing or decreasing. They are constant. We good? Let's go through it again. Increasing graph to the direction of your right hand side, decreasing graph to the direction of your left hand side, and constant graphs, which are not increasing or decreasing. It's either you have a vertical constant graph or you have a horizontal constant graph. We good? So now, how is this influenced by anything, right? Let me come here. Let me remove these things here. So starting with this one, an increasing graph. An increasing graph is caused by a positive gradient. So which means when you use this equation, you must get a negative answer, right? So which means m in this situation will be negative. So which means when you have an equation that says y is equals to mx plus c, the coefficient of x is negative. If you don't understand that now, don't worry, you will understand it soon, right? Another, in this situation here, for a decreasing graph, if your m is negative in this situation, then your graph is decreasing. Here, if your m is positive, your graph is increasing. And then here, if your m, sorry, it's not 8m. If your m is positive, then you have an increasing graph. So which means in this equation, if your m is a positive answer, what am I saying? If your m is negative, you have a decreasing graph. Negative, decreasing graph. Positive m, increasing graph. So which means here, if your m here is a negative value, then your graph is going to the direction of your left hand side. If your m value here is positive, your graph is going to the direction of your right hand side, right? And then here in this situation, for you to have these constant graphs, I'll explain these ones later, right? But just know that here m is undefined, and here just know that m is 0. For horizontal constant graphs, your m is 0. For vertical constant graphs, your m is undefined. We good? So, but you will get to understand these things sooner or later. So let's start with finding an equation of a graph that is already plotted, right? A graph is plotted, they want us to find the equation of the graph. Now, I want you to look at this graph and think of all the basics you can think of right here. Let's start with the equation. The general equation says y is equals to ax plus q. I'm going to use this equation. Remember, we have several equations. We have this equation here, which is the one that you will use in grade 8 and 9. And once you are in grade 10 going upwards, you use this one. So I'm going to use this one here, right? So now, and it's the same thing, guys. The same way you would understand this equation in grade 8 and 9. It's the same way you understand this one, okay? So here, y is equals to ax plus q. What is your a? Your a is your gradient. So for me to find a, I have to say a is equals to y at a minus y at b all over x at a minus x at b. And then someone will say like, but in the previous section you said yb minus ya over xb minus xa. It doesn't matter. What's important is that if here I'm starting with y at b minus y at a, the value below is supposed to be x at b minus x at a. You want your b's to be aligned together and you want your a's to be aligned together. Some people, how they do it, they would say y2 minus y1 all over x2 minus x1, which is the same thing again. Good. So now let's stick to this one that I'm using here. You can use any of the methods that I just mentioned right now. So we are saying you need to find a. A is what? A is the gradient. Now, when you are looking at this graph, it's going towards that direction. Which direction is that? That's the direction of your left hand side, right? So if it's going to the direction of your left hand side, already we know that your m is negative. This is a decreasing linear graph. Why? Because it's going to the direction of your left hand side. You see that if you raise your left hand side, this is where this graph is going. So your m should give you a negative answer because this graph is decreasing. That's one thing we know. Now, what negative answer is that? That's what we should calculate. But we know that a already it's negative because this is a decreasing graph. Now, how is that possible? You want to make your substitution. So when you give me this equation, the next thing to do is to give me your coordinates so that you can substitute the coordinates, right? So a is equals to ya minus yb all over xa minus x at b. So you have a coordinate here and you have a coordinate here. This is what you were given. And then they wrote them down for you so that you can see them. So 0 and 6, where x is 0 and y is 6, that is here. In case you don't see it, that's 0 and 6 here, right? And then 3 and 3, it's this coordinate here, 3 and 3. Remember how coordinates are. It's x and y. The first coordinate is always the x coordinate, and the second coordinate is always the y coordinate, right? So now, after writing this equation, you want to let the marker know which part of the coordinates you are choosing as coordinate A and which part of the coordinates you are choosing as coordinate B. So from these two coordinates, this one and this one, I have to label which one is A, which one is B. The order doesn't matter. You can make this your A, you can make this your B, or you can make this your A and make this your B. So I'm going to say coordinate A for me, it will be this one here, 0 and 6. And my coordinate B, in this case, it will be 3 and 3. You see that? You first write the equation, then you write your coordinates. Then you substitute. You're going to say A is equals to, what is your y at A? You go to A and the second value, that's your y value. So 6 minus, because we have a minus here, right? You want your y at B. So you go to coordinate B, you look at the y value, that is 3. You see that? Then for x at A, you go to coordinate A, the first value, that's 0. And then you want x at B. X at B, it means you go to coordinate B, the first value, that's 3, right? You see that? Now you have A is equals to, you start with the numerator, 6 minus 3 is how much? That is 3. 0 minus 3, that is negative 3. Now this means your A is, therefore A is equals to, what is 3 over negative 3? That is negative 1. Remember, we already knew that this was going to be negative. Why? Because the graph is going to the direction of the left-hand side. It means this is a decreasing linear graph. Now, with that being said, you only found one component of the equation. You found your A, right? You still need to find your Q, right? What is the Q? Now, this is easy. Let me write it down. Q is the y-intercept. If they gave you a y-intercept, then Q is your y-intercept. Easy as that, right? So this is your gradient, your A is your gradient, your Q is your y-intercept. Beautiful, easy as that, right? So let's get to it. What is your y-intercept? You go to the graph here. You look at this point. Let me use a black color here. This point here is your y-intercept. This coordinate, your y value at this y-intercept, it's your Q value, right? So this graph is crossing the Cartesian plane at 6. Therefore, you're going to say your Q is equals to 6. No further calculations needed there, right? As long as you have where your graph crosses the y-intercept, that value is your Q. And then afterwards, then you can give us the equation now. Now we can say, let's come back here. We used to have y is equals to ax plus q. But now we found the A and we found the Q. Therefore, we can substitute them. My A is what? My A is negative 1, negative 1x. My Q is what? My Q is positive 6. So I'll say positive 6. This equation here, this equation defines the graph above. Beautiful. Easy. We good? Now, let's run a different scenario now. A different scenario in this situation, it is this one here. It's not even different, it's the same. Please pause the video. It's that part again. Please pause the video, see if you can find the equation of this graph, and unpause the video to see if you found the solution. So, I assumed you've paused the video. Now, let me help you find this. First things first, you want to know the direction. The direction is the direction of the left-hand side. It means your M is negative. Therefore, this is a decreasing graph. That's the first thing we are seeing. You must be able to see that from the onset. This is a decreasing graph and your gradient is going to be negative. Oh, remember our gradient is going to be A because we're using A this time, right? So let's start there. You want to start with the general equation. General equation is y is equals to ax plus q, right? We are looking for a, we are looking for q. Let's start with q just to get it out of the way. Q, we said it's the y-intercept. What is the y-intercept? Your y-intercept is +1. Easy. That's where your mark is coming from. And then what is your a? Now, a, that's a conversation. You want to say y at b minus y at a all over x at b minus x at a. Remember, they have to be aligned. Y at a must be above x at b. Y at a must be above x at a. We good? Hope I said that right. Hope I didn't mess up. Afterwards, you give me your coordinates. Even if they are already labeled for you here, you can take them like that. You're going to give me coordinate A, you're going to give me coordinate B. What is coordinate A? You have 0 and 1. Beautiful. You see how I'm flowing now. What is coordinate B? Coordinate B, you have 1 and -3. You see that? Now you do your substitutions. Your A is equals to, make sure you put the minus already in place so that you don't get to mess things up. Things just become easier for you, right? So A is equals to, let me put that properly here, because here's a minus, here's a minus. I just substitute here in these values. Let's start with y at b. I go to b, the second value, that's -3, right? Easy. Let's go to y at a. Y at a is 1, so here I put 1. Let's go to x at b. I go to b, the x value there, that is 1. What is x at a? I go to coordinate a, the x value there, that is 0. Right. So now in this situation, my a will be equals to, what is -3, -1, that is -4. What is 1 minus 0? That is 1. Therefore, this means my a will be equals to -4. We already called that. We already knew that it was going to be negative, right? So now and then I write the answer to the question, the equation of the graph. So I'm going to say this graph was y is equals to ax plus q, but I found my a and I found my q. So my a was how much? -4. So I'm going to say -4x here. And then my q was +1, so I'm going to say +1 here. So this equation, it defines this line that we see here. Easy, beautiful, right? And then comes the story of plotting a graph, right? The story of plotting a graph. Ooh, we've done this video. It was actually longer than I thought. Oh, before we go to the story of plotting a graph, let me find a different question for you. So right here, I want you to admire the beauty of this question. This question is very nice. Very, very nice. It says find the equation of the graph below. Now, if you would, wait, is this thing off? Yeah. So now, if you'd remember, I said that. Okay. Please pause the video. Please pause the video and see if you can attempt this on your own. See how far you'll go and where do you get stuck. And then once you get stuck, unpause the video, because there is something that I want you to see, and you'll only be able to see it once you pause the video here, try the question on your own and get stuck. And then what I'm going to say, it will make better sense to you. Here, I want you to understand that the first thing that I want you to see is the gradient, right? How is the gradient of this graph? You should know by now the gradient is negative. Why? Because it's going to the direction of your left hand side. And then if the gradient is negative, it means the graph is decreasing. So this is a decreasing linear function, right? Okay, so let's start there. We know that the general equation says ax plus q, and therefore in this situation, for me to find a, I have to use the formula y at a minus y at b all over x at, no, not x at b. Remember, they have to align. So use a small eraser there. This eraser. X at A minus X at B. Right. And then afterwards, remember, you have to give me the coordinates. What is coordinate A? What is coordinate B? And then remember, you choose for yourself, unless it's given. So here, this one says B, so I'll just say 1 and 1. And coordinate A for me will be -1 and 5. Easy, right? Substitution now, I have to say A is equals to, I put that fraction there with the subtractions in between, and I substitute. Y at A, I go to A, the last coordinate is 5, so that's my Y, right? Y at B, I go to B, the last coordinate is 1, so I put 1 there. X at A, I go to A, my first coordinate is -1, so I put -1. And then X at B, I go to B, that coordinate is there, right? So now here, my numerators will give me 4 all over -2. And this for me will give me my A to be -2, which we already called it. We already said it. The gradient is negative, right? Right? So then I have to go to Q. But then what did we say? We said Q is the y-intercept of the thing, right? We said Q is the y-intercept of that. But then now here, the thing is, I can only assume that my y-intercept is happening at 3, but I don't know that, right? Let's say I don't know that. It was never shown. I only have 2 coordinates, and I have to find Q. How do I do that? So the way forward here is that you want to substitute one coordinate into the half equation. So I have my A. I'm going to substitute my A right here. So y being equals to ax plus q, I substitute my A. My A now is y is equals to -2x plus q. And now being at this point, this part here, this is what I need to move forward. Let's remove everything and be left with this now. Okay, I said I'll remove everything, but this is what I'm removing. So this equation here, I want to take one of these coordinates, this one or this one, and substitute it here so that I can find Q. Anything, any equation. So I'll choose B because it's easier. You can also use A, anything. Just use one of the equations. So I'm going to say, after this step here, I'm going to write the coordinate here. My coordinate is 1 and 1. And I want to sub that into the equation. So which means this coordinate is in the form of x and y. Remember that, right? So which means here, I'll substitute y here. I'll substitute x here and then solve for q. Like a general algebraic equation, right? So where there is y, I'll put a y value there. What is the y value? The y value is 1. So I'm going to say 1 is equals to -2 in brackets. Where there is x, I have to put my x value there, which is 1. Then I'm going to say plus q. Then I solve for q here. So I have 1 is equals to -2 times 1, that is -2 plus q, right? And then I have to send 2 to the other side now. So sending 2 to the other side this way, it means I'll have 1 minus, the 2 is already negative. So once it gets here, it changes the sign. It becomes a positive q, right? Therefore, which means my q is equals to how much? What is 1 plus that is 3, right? Right there. So I found my q, which we did assume it was 3. I found my q to be 3. I have my a already, and now I can write the equation. My equation from being y is equals to -2x plus q. I now found the q. Therefore, I'm going to say -2x plus my q is 3. 3 is the equation for this graph right here. You see that if you don't have your y-intercept, or you're not sure about your y-intercept, substitute one of the coordinates to find your y-intercept, and that gives you your q. You get what I'm saying? If you don't have your y-intercept, substitute any of these coordinates into the half equation like we did here, so you can find your q value. Easy as that. Now the next part. Oh, this for a linear function. This video is becoming long now. The next part. I want you to understand plotting. If there is anyone who'll ever have problems with plotting, we are going to have a problem. Seriously. If there's anyone who will ever have a problem with plotting, I don't know, guys. You have zero reasons to have a problem with plotting. Here's a question. The question says, sketch the graph of P of X. Look at the beauty in this. Sketch the graph of P of X. I want to do something to this question so that it becomes a beautiful question. It's not perfect now. It will only become perfect if I add some small change to it, right? Perfect. Now this is how the question frequently appears. Frequently, they would say sketch the graph of P of X using the intercept method, or sometimes they just say, or sometimes the question just ends here. Most of the time, the question just ends here. Sketch the graph of P of X. They don't tell you what to use or anything. They just say this. Sketch the graph of P of X. And then the best way to plot a graph is to use what we call the intercept method. Forget the what intercept method. The best way to plot the graph is to use the intercept method. It's way too easy. Too easy. Which means here, I want you to get me coordinates of the x-intercept and get me coordinates of the y-intercept. Y-intercept is not even going to be a lot. Let me put it here. So now in these situations, there are some things you are supposed to understand. On the x-intercept, let me put this in red so that you can remember it. Y is always 0. On the y-intercept, x is always 0. On the x-intercept, y is always 0. On the y-intercept, x is always 0. That way. So which means given this equation, which is P of x is equals to 1 over 2x minus 3. You're supposed to understand that P of x is the same thing as y. So here I can replace P of x with y. And then what did I say? I said y is 0. Right? So, which means here, where there is y, based on this statement, where there is y, I'll put 0. And then I solve for x. Right? How do we solve for x? We transpose 3 to the other side. It becomes positive 3 is equals to 1 over 2x. And then I continue solving for x here. How do I send 1 over 2 to the next side? I have to do the opposite of what we have. So 3, let me put an equal sign here, 1 over 2x. How do I remove the 1 over 2? I have to do the opposite of what I have. It's 1 over 2. I'll multiply with 2 over 1, which means this side I also have to multiply with 2 over 1. So the 1 over 2 will be cancelled by the 2 over 1. We call this the reciprocative inverse because the inverse of 1 over 2 is 2 over 1. And then in this situation here, what is 2 over 1? 2 over 1 is 2. So 3 times 2 is equals to x, right? 2 over 1 is 2. So 3 times 2, that is 6, which means our x is 6. Right. So now, I have the x value. I have the y value. which means I can now form a coordinate. Therefore, the coordinate of the x-intercept, x is 6 and y is 0. I have a coordinate there. Easy as that. You have to remember that. Let me write it here. No, it's fine here. It's fine here. The next part, I have to get the x-intercept. The y-intercept. So from the equation whereby I'm saying y is equals to 1 over 2x minus 3. Where do I get this? I get this from here, right? Remember that p of x is the same as y, right? So we said x is 0, which means I have y is equals to 1 over 2 multiplied by 0 is equals to 3. Why? Because on the y-intercept, x is always 0. We're good. So now from that point, I'm going to say y is equals to, what is half times 0? When you multiply anything with 0, it becomes 0. So then the minus 3. Therefore, my y will be equals to negative 3. So I have my y here, and I have my x value as 0. I can now write the coordinate. Therefore, the coordinate here will be what? I said my x is what? My x is 0. So I put 0 as the first coordinate. And my y value is what? My y value is negative 3. You see that? So actually, I have two coordinates here. From these two coordinates, I can create the graph. Two coordinates, that's all I need to create the graph. Oops, is this thing still visible? Yes. My mouse just disconnected. Let me fix that. So now, I'm going to draw a Cartesian plane quickly. Like that. Like that. Right. So, what do I need? I need an x value of 6, a y value of 0. I need an x value of 0 and a y value of negative 3. All right. So let's start with the highest values. X of 6. So here x is supposed to be 6. And then, that is y, sorry. What am I doing? When I'm almost done like that. So we are saying x, I need it to be 6. It's the x-axis, this is the y-axis, this is the origin here, right? So x needs to be 6. I need my lowest y value to be negative 3. Right. So this coordinate here, x is 6, y is 0. So the coordinate is there. Put a dot here. And then this coordinate is on the y-intercept. X is 0, y is negative 3. I put a dot here. And then I join these two things with a straight line like that. That's a graph. That's a graph. And then I label my graph. This is the graph of p of x. Easy. If this thing is 3 marks or 4 marks, easy, 4 marks there. Where are the marks, if you may ask? 1 mark for this intercept, 1 mark for this intercept, 1 mark for the shape of the graph, 1 mark for labeling, and there you go. 4 marks, easy as that. Plotting the graph, here's your 4 marks. Beautiful, right? So I hope this won't give you a problem, guys. So guys, if you've reached this part of the video, please don't forget to subscribe to Manala's Arc. As you can see here, we are sitting comfortably exactly at 600 subscribers with 46 videos. Thank you for that again. Those of you who subscribed and those of you who keep on watching. For those of you who haven't subscribed, please subscribe to the channel. And what is that thing? What is that thing? Hit the notification bell so that you can be notified when I drop a video next time. Don't forget to like the video and comment if you have anything to say there, maybe any question, you are lost somewhere or you need us to do something else. And I'm done for now. Goodbye. See you on the next video.